Hi everyone and welcome to this DSA Mastery course, and in this video we will be talking about one of the operations in a linked list, which is inserting a node in a linked list. As we have already talked about traversing a linked list and in the previous video, but in this video we'll talk about inserting a node in the linked list, okay, at a given position. Okay, means in any position you want to insert. Okay, so what I'm planning is, let's take an example that we have an input. Let's say we are given an input, let's say 3, 4, 5, 6, 7 and 8. Okay, so this is our input. So what we have to do, let's take an example that we call our function insert, and we have given a head, and also we have given the position. Let's say we want to insert at the position is 0, 1, 2, 3, 4, 5. Okay, so let's say you want to insert at third position. Okay, so the output would be the 3, 4. Then we have a what to insert. Let's take an example that you want to insert 10. This third position means here, not here. It is here. 10. Then it is 5, 6, 7, 8. This is the new thing that we have inserted. So we will take one more also, means this is the position which we have to insert, and this is the what data to be inserted there. Okay, pretty much is what I'm trying to say here. Okay, so this is our output. Okay, so what actually our initial plan is that, let's take an example that you want to insert here. You want to insert here at the third index. I'm saying third index. Okay, so you're going to insert a node at the third index. So how you will proceed? So proceeding that, you will traverse, means what is the initial plan? Let's take an example 3, 4, 5, 6, 7 and 8. You want to insert at this position at the third index. Okay, so how do we do that? For doing that, we can either, this contains the pointer to this, means this is the node that contains the data, this is the data, and this is the next, so it is pointing to next. This kind of, what I can say, the node is being pointed by the previous node. And what if I could do, if I could make this point to the new node, this 10, and make this new node point to 7. Are you understanding what I'm trying to say here? Let's take it again, and again I'm explaining what we have to do. Let's take an example. We have let me delete this. Yeah, so let's say you want to delete insert here. Okay, so what we can do, you wanted to insert 10 at the second position or any position, let's say here. Okay, so you insert it here. So what you can do, you can, this is our previous, we have to come till here, position -1, means what is the position? We have to come till the position -1, means if this is the position that we have to insert, we'll come it here, and then it contains it is pointing to 6, so it is being, and here is our new node that we have to insert. So if we do that, his next is pointing to this, and his next is pointing to this, and this will be easy. Okay, so we have inserted in between. Okay, it may happen that you are not able to understand. Don't worry about it. I will explain you just in a second. But let's write a code, then you will understand it much better than writing a concept over here. Okay, so here is my Eclipse that is open, and let me delete this, it's not needed. Okay, so I will make a static, means like function, public static function, means void. First we will say void, because we have to insert, and first we will take void, means it is not returning anything. So it will, our function name is insert, and it takes head. It is necessary to get head, and then it will take data, and then it will take position to be inserted. Okay, this is our initial plan is, and then I'll make it further. I think you all are able to see this. Okay, so what we will do, we will first of all, we will go till the position -1. Okay, so we'll go till the position -1, as we have already talked about how do we take a step. We take one step by head equals to head dot next. What does it mean? It starts pointing to another, and it's until and unless we reach out to this condition. Okay, so in the same way we'll make one I equals to 0, okay, and we'll also make a temp that will contain our head, because we don't want to destroy our head. So, or I can say node integer, we will also make temp that will store our head, and then we will traverse it till the position -1. So what will be the condition? Condition would be we have to go till position -1, means this is a position and we have to go till here. Okay, so it's smaller than position -1. Okay, this is our plan is. And then what we have to do, we have to take one step further, means if we have gone till here, means let's take an example, this is aura, and head contains this, and this next pointing to this. So if I make head equals to head dot next, so 3 dot next, now it is will start pointing to 4 until and unless we reach out to the while loop condition. Okay, and the condition is position -1. So in this case we have a temp equals to the temp dot next, and we have to, by the way, increment the I. Okay, so this is our plan is. Okay, and one more thing we have to do, this is our data that we have taken, but who will convert this data into a node? So for that we will make a node, means we only get the integer, not the full node. So for converting the node, we want like that, integer, then we have a new node equals to the new node and takes data. Okay, so it takes data, and then what we will do is that this is our data, and then this is our new node. So what's our initial test plan is, this is our temp is in position -1, temp dot next should start pointing to new node, temp dot next should start pointing to new node, and new node dot next should start pointing to the next node, means temp dot next node. What I'm saying here, and first of all, let me make you familiar with what I'm saying. So I'm saying that this is your 3, 4, 10 and 5. This is and you have to insert here at this position. So we have till here position -1. We are here, and if we do this is our new node. This is our new node to be inserted. So if we do temp dot next equals to this new node, okay, temp dot next equals to new node, and this next to be this. Okay, and now it will be inserted. So that's what I'm saying. So what you can do is you can simply add temp dot next equals to the new node, and that will start pointing to the new node. Okay, now temp dot next previous is start pointing to node, and this one means new node, and then what will happen, and new node dot next should start pointing to temp dot next, temp dot next. Okay, is this achievable position? Is this will achieve our position? No, it will not achieve our position, because now we have lost our connection. Means temp dot next, this is the way this was containing this node. If we unlink this to this, how will we reach out to here? So if we do it above and then if we do it below, this will be perfect. Like what I'm doing is that if we take new node dot next, we will start pointing to this, and then we can make, and then if we shuffle up over here, and I will shuffle up over here. Okay, now it will work fine. How it will work fine? Because what we are doing, if we do this first, what will happen? This is the temp dot next will start pointing to new node. Now we have lost our link to this node, means the next node, and we lost our whole link list, this node. Okay, so what we are doing, we have in the next point, we will be in this next new node dot next will be start pointing to this 10, and then temp dot next will start pointing to the new node, and this will be okay. Okay, can we take a look at this? And okay, done. What I can do, I can simply go over here and write insert, and it takes head, and let's take an example. You want to insert, let's say 20 has already been, let's take an example 70 at the second position. Okay, so you want to insert, and then we will print out our head. And again, print traversing function has already been written above. Do check out my previous video, then you can understand like that. Okay, so you can see 20 has been inserted, 70 has been inserted at the second index. Okay, this is how it works. But what if first of all, let's do the dry run so that you can understand a little bit much better. So let's wait for a second to be loaded, this epic pen. Okay, so this list example, this is our 10, 20, 70, sorry, it's not 70, this is a 10, 20, 30, 40 and 50. This is our node. Okay, we want to insert 70 as a second index. So this is our second index. We want to insert it here. So what will happen? It will go till here, means it will make a new node of this 70. Now 70 will be this contains null. Now this is a null. This is the node of 70 from this. And then what will happen? A temp will store this head, temp will store, and then it traverse it until and unless position -1. So how to traverse? We start pointing this next to this. So now we'll start temp will be pointing to this. Okay, this 20. Now what will happen? We have position -1. Now we will increment. Now we'll stop there. Now temp contains 20. Now temp equals to 20 because this is a position -1. This is our new node 70. Now in the new node dot next is containing null. Now if we can point new node this 720 this null to the 30, means this is our temp which contains 20 node, this node, and the next it has address of 30. So if we take new node dot next equals to the, if you start pointing to this, if our new node start pointing to this and temp dot next start pointing to the new node, means what we are doing it here and we are putting up there. Okay, and this is what we are doing in our dry run. Okay, so what's one more cause here, means one more bug will come here, that it is not inserting at a 0th index. We want to insert it at a 0th index. Why it is not inserting there? It is inserting at a first index. So this is some of the problem. What is the problem here is that we can write the simple if statement, means if you want to insert at the first position, at the first index. So what we can do, we can make the head equals to the head equals to the new node. We can do this. Either we can do this, yeah, we can do this. So let's do that. And if our position is equals to 0, what I can do, new node dot next will contain head. Okay, and then we are good to go. But if we save this, and what we are doing, we have a new node, and next we are containing 10. So we have already we have in first our new node. And then if I save this, I hope that nothing error is happening. Yeah. So if I save this again, it has not saved us. But what is the reason behind that? It is only doing itself. Main has its own head and is doing in his own head. But what we have to do, we have to return something, and we have to update our head that this is our updated head. We have to tell main to update our head. So, and then it will return, new node, and then it will return obviously the head. Okay, so we are not doing anything with the head, so it will return head. Okay, so if I save this and update it head, now we have updated our head, save this and run this, so you can see 70 has been inserted at the 0th position. Okay, so this is what we are doing. We are just going to the position -1. We are making the next this pointer. We are pointing to this node, new node, and the new node dot next will be starting pointing to the temp dot next node that we have previously. Okay, this node. this is the very simple approach that you will have to just take a pen, write an input and output, what will be the, and just find the relation how we can proceed further in that way. Okay, so that's it for this video. In the next video, I'll be bringing up a deletion of a node in a linked list, and then we'll doing some more problems or operations like printing printing ith node, length of the linked list iteratively, midpoint of a linked list without taking out the length, etc. Okay, so that's it for this video. I'll be catching up in the next video. Till then, bye bye.